This video is for synthetic division, which is the second part of section 3.3. So there's a shortcut for dividing polynomials, right? If you're starting off with long division, then by definition it's long, and there's a shortcut for that called synthetic division. But it only works when you're dividing polynomials by binomials of the form x minus k. So in this case, in this example, we'll divide negative x cubed plus 4x squared plus 9 divided by x minus 3. Other examples, so out of these, remember, like, part of the shortcut is that it only works when we are dividing by binomials of the form x minus k. So on this page, this is your student journal, by the way, we can do this problem using synthetic division because we're dividing by x minus 3, but it doesn't work here, doesn't work here, it also doesn't work here. So we cannot do synthetic on any of those. And just to show you how it goes, I will go over this problem, and then I will also show you this one. It has a placeholder value, so I will leave that one for second, and I'll do this one first. So I'm going to do this structure. This 3 comes from here. So again, whatever we are dividing by should take the form x minus k. And in this case, k is equal to 3. So that goes right there. Then I'm just going to write down the coefficients. So 1x squared, positive 6, positive 12. And then we're going to start off by bringing this down. 1 and 3 times 1. And then we're going to pretty much do the same thing in terms of long division, except instead of multiplying and subtracting, we'll be multiplying and adding. So 3 times 1 is 3. 6 plus 3 is 9. 3 times 9 is 27. 12 plus 27 is 39. And the way the answer goes is, which, by the way, if you watched last video, we already did this. It's x plus 9 and 39 is the remainder. This is the remainder. If it's a 0, then there is no remainder. So x squared plus 6x plus 12 divided by x minus 3 is 1x plus 9 plus 39 over x minus 3. So one thing you'll kind of notice is that in the problem, this starts off at 1x squared, 6x, but we don't need to do that when we do synthetic. Like, the point of it is a shortcut, so we don't have to write those things out, but that's just what it is. And this is just one, the exponent is 1 degree less. Or if you're starting at the end, then this is the remainder. We have no x, 1x, x squared, x cubed, x to the 4th, and so on and so forth. So let's take a look at the book example. So I wanted to hold off on this one to show you a simple example, and I'm going to show you one with synthetic, but also with a placeholder. So we do not have a term with, like, after x squared, there's nothing with an x, right? So I'm going to go ahead and start off by writing the k value. X minus 3 means that k is 3. If the problem was divide by x plus 3, then that means it's x minus negative 3, and I would put a negative 3 there if I was dividing by x plus 3, but we're not, so we don't have to worry about it. So write the coefficients down: negative 1, positive 4, 0 as a placeholder, then 9. So again, first step, bring this down, multiply. 3 times negative 1 is negative 3. Then add 4 plus negative 3 is 1. Multiply, 3 times 1 is 3. Add 0 plus 3 is 3. Multiply, 3 times 3 is 9. And then add. So this is my remainder. I have 3, I have x, and I have negative x squared. So negative x squared plus x plus 3 plus 18 over x minus 3. So that's synthetic division. Again, it's just a shortcut, but it only works when we are dividing by some binomial of the form x minus k. So x minus some number, x plus some number. But to show you things it doesn't work for, we cannot use it for this because this is x squared. We cannot use it for this because it's 4x. And we cannot use it for this because it starts off with x squared. Yeah, and this is not a k, it's an x. So yeah, that's synthetic division. It's a shortcut, should make your life easier. But for sure, I understand that it's tough to familiarize yourself with it. So if you have any questions, please let us know.